In example 12.1, we are asked to use the definition 12.1 to define the degree 2 polynomial parent function over the largest possible domain. Then graph the function you defined. So first things first, from definition 12.1, the general equation for the polynomial that's degree 2 would be y equals ax squared plus bx plus c. Now, this particular polynomial is based off of one of our parent functions. The parent function that this is based off of is y equals x squared. It's the squaring function. So I have to choose the correct values for a, b, and c to make the parent function show up. Now remember, there's one stipulation that says a is not allowed to be 0. And the reason for that stipulation is because if that's 0, then the entire x squared term goes away. And then all you're left with is a degree 1 polynomial, which then becomes linear. It's not quadratic at all anymore. So we want to be sure to stay away from that possibility. So we don't want to choose a to be 0. Instead, we're going to let a be equal to 1, b equals 0, and c also equals 0. When we make these choices for a, b, and c, it's going to say y equals 1 times x squared plus 0 times x plus 0. And once all the arithmetic is done, the final result is just y equals x squared. That's what the equation looks like for the parent function of a degree 2 polynomial. We are asked to define the degree 2 polynomial parent function. So it's not just about having the equation, we need to also have the domain involved. And it does say in the instruction to use the largest possible domain. So remember, there's two things that we're concerned with when we're looking at domain: division by 0 and square rooting a negative value. The good news is there is no square rooting going on and there's no division going on. So the largest possible domain would be all real numbers. So let's write out our function definition. We're going to give our function a name. I'm going to call it f. The domain will be all real numbers. The domain is always supposed to map to other real numbers given by f of x is equal to x squared. And then when we graph our parent function, starts at 0, 0. We have a point at 1, 1, negative 1, 1, 2, 4, and then also negative 2, 4. And this gives us the shape of the squaring function, which we call parabola shaped. And we'll point out a few things that are here on this as well. Number one, we have the vertex, which is possibly the most important point when you're talking about graphing a quadratic function. If you can find the location of the vertex, then you can usually get the rest of the graph completed. There is also a axis of symmetry. The parabola over this large domain is going to have two halves, a left half and a right half, and that axis of symmetry, I'll abbreviate that AOS, axis of symmetry, always crosses through the vertex vertically like this. And we'll also notice that it opens up. And we'll get into more detail about opening up, opening down in terms of transformations on some other examples.